Hi, so in this video, I want to talk a little bit about Ethernet and Ethernet MAC addresses and how Ethernet forwards frames from one NIC to another. But first, we got to talk a little bit about IP, in this case, IPv4. So if you notice here, we have two IPv4 networks. We have one IPv4 network here. And don't worry, if we haven't gotten to IP yet, we will. Talking to my students, but anyway. So you don't need to know about IP, but kind of in general, notice that all the devices on this side of the router have the IPv4 address starting with, in blue, 192.168.1. On the other side, they belong to a different network. They all have the first two digits in common, 10.1. So devices on the same IP network, which IP addresses are set in software, must have the same network portion in common. Okay. So on this side of the router, these devices are on the same IP network, and these devices are on the same network on this side of the router. Notice that the router belongs to two IPv4 networks. It has an address for each one and an Ethernet NIC card on each one. Okay, so as far as Ethernet goes, let me talk a little bit more about Ethernet. We have Ethernet NIC cards here. The MAC address is a 48-bit address represented in hexadecimal. To make it easier to refer to, I'm using the last four digits of the hexadecimal digit right here. Now, Ethernet does not care about IP, doesn't care about what kind of data it's carrying. But when we implement our IP networks, we care about what side of the Ethernet LAN it's on. Basically, what I'm saying here is we have a router here. And again, notice that all these IP addresses on this network are on one side, and all these IP addresses are on this side for this other network. We'll talk more about that later. Okay, so yes, all the IP addresses that are on the same network must be on the same side of the router. Now, for those of you that know things like a little bit about VLANs and router on a stick and some other things, yes, there's other ways to implement this same concept, even being on this, having two IP networks on the same side of the router. But let's not worry about that right now. All right, so we have this IP network on this side and this IP network on the other side. Okay, why? Okay, so let's take a look at how PC3 down here in the corner sees the network. It doesn't. It's in a bubble. The only thing PC3 knows is, well, it knows its own Ethernet MAC address. It's on the NIC card. And it has either been statically configured or dynamically assigned an IPv4 address, subnet mask, and default gateway address, the address of the router. But don't worry about that right now. What to recognize is it doesn't see the network. It only sees itself. So what IP addresses are directly reachable? Okay, as far as what's directly reachable from PC3's perspective is the other IP addresses on its network. Now, yes, it can send packets to devices on other IP networks. We'll see that in a moment, okay? But what it sees as directly reachable is really only devices on its own IP network. That will make a little bit more sense in a moment. What is reachable via Ethernet? Well, what's reachable via Ethernet is only those NIC cards, those Ethernet NIC cards, on the same side of the router as itself. All right, so you may be a little, what? I'm not sure how all this works, Rick. Let's take a look at how this all works in action. All right, let's go from PC2 here to PC0. Okay, now PC2 knows its own IPv4 address. So we're going to build the packet here. It knows the destination IPv4 address of PC2, 192.168.1.100. Now, you might be asking, how does it know that? We'll talk about that later. It uses something called DNS. Typically, usually we don't use IP addresses, unless like up here in the corner here, oh, we do know the IP address. But typically, as users, we don't use IP addresses. Okay, but what's important here is that PC2 recognizes that these two IP addresses are on the same network. Again, PC2 doesn't see this, doesn't see the topology, it's in a bubble. But if you notice that the first 3 digits of the two IP addresses are in common, doesn't have to be 3 digits, okay? Talk about that later, okay? That's why I've got later here. But let's just say, for the sake of this scenario, that it does, PC2 knows that this destination IP address is in the same IP network as itself. So it's going to build an Ethernet frame, use its own MAC address as the source MAC address, and it knows that since we are on the same network, the two IP addresses, this means I must be able to reach you directly. Remember, I mentioned that earlier. Okay, this is why we have our IP addresses on the same side of the router. Devices in the same IP network on the same side of the router. So it says, okay, I know I can send this packet directly to you. Now you may be wondering, how does it know the MAC address of this destination IP address of PC2? We'll talk about that in a later video called ARP, Address Resolution Protocol. All right. So let's finish building the frame. It says here, oh, Ethernet likes to know what data it's carrying, what the payload is. There's the frame check sequence for error control. We're on our way here, and now this frame can be delivered. Ethernet can deliver this frame from this NIC card to this NIC card. Okay, and we're going to talk about these switches later, so don't worry about that right now. All right. You notice this your turn stuff? Whenever you see that in this video, that's a little exercise that we do in class with my students. All right, so let's do another one. PC0 to PC1 down here. PC0 is going to build the packet and the frame. Okay, the source IP address, 192.168.1.100. It knows its own IPv4 address. And using DNS, or we typed it in, it knows the destination IP address. Once again, same IPv4 network. Okay, that's recognized by PC0. Yes, I see that you're on my network. That means I can encapsulate this in an Ethernet frame. That's going to go from my network interface card. There's the source MAC address of my Ethernet NIC card. I know that because it's my NIC card. The Ethernet frame is being built by my Ethernet process and Ethernet NIC. Okay, as far as the destination MAC address, hey, we're on the same IP network. That means that our NIC cards must also be on the same side of the router. Okay, so there we go. We'll put in the destination MAC. Oh, that's PC1, the MAC address that's associated with this destination IP address, same device. Okay, again, let's not worry about how it knows the destination MAC address. That's the ARP process. Okay, the payload being carried is IPv4, frame check sequence. We can send it from that NIC card to that NIC card. All right, so how we doing? Hopefully this is making sense. All right, so what about PC1 to PC2? Let's just do one more in the same network. Don't worry, we're going to see what happens sending something to another network in a moment. All right, so PC1 says my IP address is 192.168.1.101. The destination IP address is 192.168.1.102. Same IP network again. Great. That means I can send it from my MAC address, my NIC card. So that's the MAC address of my NIC card. And I'm going to send it to PC2's NIC card, its MAC address. Okay, again, type is IPv4, frame check sequence, boom, on its way. We're looking good. All right, now you may be wondering, but Rick, many times, most of the times, I'm sending packets to the internet or, another network. All right, so what do we do in this case? All right, so this is why you have a default gateway IP address. Okay, so let's take a look. PC1 is going to send a packet to server 0. Okay, so let's see. PC1 says my source IPv4 address is 192.168.1.101. Okay, destination IPv4 address 10.1.0.99. Now you can kind of see this, right? Okay, and we'll learn later how IPv4 makes this determination, but we're on different IP networks. Look at this. None of our addressing is the same. Okay. All right. So it says, all right, I'm going to send this from my MAC address, my NIC card. There's my source MAC address. However, I can't send this directly to you. You're on, I know where you are. Remember, I'm in a bubble. I don't know that you're on the other side of the router. For all I know, you're in many routers away. I don't know. I don't care. All I know is I have an IPv4 address of my local post office, my default gateway. I need to know this IP address because this is who I'm going to be sending Ethernet frames to for any IP packet, any destination IP address that is not on my network. I don't care where you are, on the other side or beyond, but you're not on my IP network, and that's all I care about. So I know my destination IP, the IP address of my default gateway, 192.168.1.1. What I need is its MAC address. So there it is right there. Its MAC address is 9E26 using, using the last 4 hexadecimal digits. Now, how did it know that? Again, the ARP process. We'll get to that in a later video. But we're going to count, so the type field is IPv4, frame check sequence. So it's going to go from my Ethernet NIC card, not to the NIC card of the destination. We don't know where you are. All I know is I can't reach you. You're not on my side of the router. I'm going to send it to my local router, my default gateway's Ethernet NIC card, its MAC address. Okay. Basically, anything, if you're wondering, anything that's being sent from these devices here, these 4 PCs, that is going anywhere outside this IP network, they're always going to, their Ethernet frame is going to be the destination MAC address of their default gateway, the local router. You'll notice they all have the same default gateway IP address. They'll all send it to the same destination MAC address for anything that is not on their network. Okay. All right. So now what happens? The router receives this Ethernet frame. We're not done yet, are we? Okay. Because it hasn't gotten to the server yet. The router receives this. It says, yes, that's my MAC address, 9E26. Let me de-encapsulate this Ethernet frame. Let me look up the destination IP address. I'm going to look it up in something called my routing table. We'll talk about that later. But my routing table tells me, hey, this destination IP address is on one of my, we call it directly connected networks. Okay, so what does that mean? That means I can send it from me to, well, from my NIC card, let's start there, my Ethernet NIC card. Remember, it came in on this NIC card. It's going out a different interface, different Ethernet NIC. Okay, its source MAC address is going to send it out of it is EC01. And it says, well, you're actually on the same side as me. We share the same network. We talk about this later in routing and stuff, but I'm able to send it from my Ethernet NIC card to your Ethernet NIC card. Okay. And it's on IPv4 and frame check sequence. And there we go. From this NIC card to this NIC card. Same IP packet. Okay. Different Ethernet frame. All right. So let's go back. What happens if server 0 is now sending a packet back to PC1? Okay, so it's going to build the packet 10.1.0.99, and it says, okay, great. This is my source IP address. I'm going to send you some return data. You're 192.168.1.101. I recognize we're on 2 different IP networks. I'm going to send it from my Ethernet NIC card, 6767. Okay. But I've got to send this to my local post office, my default gateway, which is 10.1.0.1. Oh, yeah, right here. Okay, but it doesn't see it. It's in a bubble. Okay, so I'm going to send it to the MAC address of that default gateway, which ends in EC01. Again, it learns this via the ARP process. Talk about that later. A lot of laters here. Okay, it's going to put the type field, frame check sequence. It's been now encapsulated in the Ethernet frame, and it can be sent from that NIC card to that NIC card. Ethernet frames are only good on one side of the router. Once the router receives it, once the router gets this, it says, hey, oh, the Ethernet frame, destination MAC address, EC01, that's me. Let me de-encapsulate this frame. Okay. Now it's again going to look at the destination IPv4 address. It says, oh yeah, that's on one of my other directly connected networks. It's going to build a new Ethernet frame. Okay. It recognizes that it's going to send it out a different Ethernet NIC card than the one it came in, 9E26, last 4 hexadecimal digits, source MAC address. Destination MAC address will be that of the destination, because it's on its same IP network, same NIC card to NIC card here. I can send it directly out this interface. So it's going to send it to 79E9, finish the rest of the encapsulation, and send it on its way. All right, I hope this is making sense. We got a little bit more to go here. What if we have PC3 way over here, 2 routers along the way, and server 0? All right, let's take a look. So it's going to build a packet, PC3. Okay, source IP address itself, destination IP address way over here. Okay, recognizes 2 different IP networks. PC3 recognizes this. Okay, so what it's going to do is encapsulate it in an Ethernet frame with its own source MAC address. Okay, but it's going to use the destination MAC address of its local default gateway. Its local default gateway, this router here, 192.168.1.1, it has this MAC address. It ends in 9E26. So it's going to send it from this NIC card to this NIC card on the same side of the router. Now, when this wireless router receives it, let's say it's like a home router, that's what your home router does. It receives it, says, oh, 9E26, yep, that's me. Okay, let me de-encapsulate that frame. I'm actually building it down here, making it easier for my PowerPoint animations. All right, same packet though. It says, it looks this destination address up in its routing table and says, oh, okay, I know how to get to you, but you're not on one of my directly connected networks. I do not have an interface that belongs to that network. But my routing table tells me, just like the post office, it's like the Monterey post office here locally to me, saying, oh, I've got something to send to New York. Oh, that's not my neighborhood, so I'll send it to the San Jose post office. Same thing here. This router's routing table says, just let's encapsulate it into a frame and send it to a next hop router, a local next hop router on its way to the final destination. So its routing table tells us we're going to send this out the EC01 interface, this interface here, this Ethernet MAC address, EC01. The destination MAC address will be DC02. We have a new Ethernet frame. It's going to go out wireless router 0 to, I guess, regular router 0, receives it. Okay. All right, now let's see what happens. Router 0 receives this, says, oh, DC02, destination MAC address. That's my MAC address right here. I received that frame on. Let me de-encapsulate that. Oh, destination IPv4 address, 172.16.1.99. Hey, I recognize that. My routing table tells me I'm directly connected to that network. I can get there directly. So what I'm going to do, put that right down here. Going to send it out a different Ethernet NIC, a different interface. Going to send it out my Ethernet NIC with the MAC address ABCD. That's my source MAC address. I can send this directly to the final destination, in this case, 172.16.1.99, and its MAC address is 6767. Again, ARP. Okay, whether you're PC3, wireless router 0, or router 0, learning destination MAC addresses is the ARP process, address resolution protocol. We talk about that later. Going to finish the encapsulation here, send it from ABCD to 6767. So what you've seen here is the same IP packet, the same source and destination addresses throughout. The only thing that has changed in this case is the source and destination MAC addresses from hop to hop. All right, we are going to talk about IP later, source and destination IPv4 addresses. And for those that are wondering, we will talk about something called network address translation, but let's wait until we get there. All right, hope you enjoyed this. I hope it helped. Have a great rest of your day.